Hey there, hope everyone's doing great. In this video, we're going to talk about appending, so appending nodes to the end of a list, and inserting nodes somewhere in the list. You give me an index and I will insert a node there. All right, here is append. It's rather straightforward. It's basically just going to take an item and we're going to create a new node with that item. Now what we're going to do is basically see if the head is none. So if the head is none, we're trying to append to an empty list. So all we have to do is set the head to be the new node. And then importantly, you need to return. If you don't return there, the rest of this code down here is going to execute and do some weird stuff. But if you're doing an empty list, just set the head to the new node and return. Otherwise, we're going to go down here and all we're going to do is traverse the entire list. So we're going to traverse the entire list all the way until we find a node whose next value is none. Once we find a node whose next value is none, that means we're at the tail, and we just set the current node's next property, because that's going to be equal to the last node. We set its next property to be the new node we created. If you are using an implementation that has a tail pointer on your class, like I have the head pointer but not a tail pointer yet, I'm going to create one here in a few videos. But this is very easy to do. You just basically take your self.tail, set it equal to the next node, and then, set it equal to the new node, and then set the new node to be the tail. But I'm not using a tail, so when I do create a tail, I'll come back and look at this function again. Here's the insert. It's a little bit more complicated. We're going to take a item and a position. The position being the index we want to insert it at, and the item being whatever data value we want to create. We need to keep track of a few different variables. So we need to keep track of the current node, just like normal, right? Whatever node we're currently at. We also need to keep track of the previous node. We've seen this before in the remove function. And we need to keep track of what position we're at. Okay. Now we're going to enter this while loop. And I'm basically going to loop as long as the current node evaluates to something. Okay. If this current node evaluates to false, we're going to break out of this while loop and then go on with the rest of the function. But while we actually have a node, we're going to check, is the current position that we're at, is that equal to the position that I wanted to insert it at? If it is, we're going to break out of this function, we're going to break out of the while loop because we found the node in which we want to insert at. All right, so that's why we break if the current position is equivalent to the position that the user added in the index we're trying to insert it at. Otherwise, if it's not, if current position is not equal to the position that we're trying to insert at, we're going to update that previous node. Remember, it's super important we do that previous node first. Then we're going to come down here and move our current node one to the right using current node.getNext, and we're going to increment, we're going to add one to that current position variable. And we're going to continue this whole process until current position is equal to position, or current node evaluates to false, which basically means I'm at the end of my list, or I've gone outside of my list. Okay, so once we're out of this while loop, we're going to check this condition. If current node is none, so this is going to happen in two instances. This is going to happen for an empty list, because if I have an empty list here that just looks just like this, well, guess what? I'm going to go up here. My current node is going to be set to the head. The head for an empty list is none. So when I get down to this while loop, the current node's going to evaluate to none, which is not going to pass. It's not going to execute. We're not even going to go inside of this while loop here. We're done with it. We're just going to go down here, and current node is going to be none. So I'm saying, hey, if you're trying to insert at any index, I don't care. It could even be index 0 in an empty list. I'm going to raise an error. You don't necessarily need to do this. You could return false, or you could check if it's inserting at 0. If it is, just plop it onto the head. You can do many things, but I'm just going to say, hey, if you're trying to insert at any position in an empty list, it's going to raise an index error. The other time this is going to happen is if my current position, or excuse me, my current node evaluates to false. And that's going to happen when I'm outside of my list. So if I have lists of like 23, 17, or 18, and 20, these indexes are 0, 1, and 2. So if you tell me you want me to pass something in, you want me to insert at position 3, we're going to keep going through this while loop, basically those 3 times, and eventually this current node is going to be outside of our list. It's going to evaluate to false. We're going to break out of the while loop. We're going to come down here. The current node is going to be none, so we raise an index error. So those are the 2 situations. You're trying to insert anything into an empty list, or you're trying to insert something at an index which is out of the bounds of the list, is when that's going to execute. Otherwise, if we get all the way down here, we know we're not dealing with an empty list, and we know that the index you passed me is not outside of the list. So we're going to create a new node right there because we need to insert it. Then we need to check one thing. Is the previous node none? The previous node is going to be none if we are inserting at the head of the list. Okay, so if I have a list that, just has one value in it, 17, and I'm coming in here, I want you to insert at position 0. Well, we're going to say the current node is going to equal the self.head. In this case, that's going to point to 17, so that's fine. My previous node is going to be none. By default, my current position is going to be 0. I'm going to say while current node. Well, current node is going to be the head, which points to 17, so it does have a node value. So we're going to jump into this while loop, and I'm going to say, is the current position, which is 0, equivalent to the position you passed in, which is 0? It is, so I'm going to break out of this loop. I'm going to come down here. Current node actually has a node value, so we're not going to go into that if conditional. We're going to come down here, and at that point in time, previous node's going to be none because I never got to this line. Remember, I broke out. I broke out of the while loop on my first iteration, so I never got to this line. Let me get rid of all these arrows here. I never got to this line where it actually assigned the previous node. So the previous node's going to be none. That means you're inserting at the head. To insert at the head, it's pretty easy. You just take the new node and you set its next property to be the head. Then you take the head and set it to be the new node. I'll show you this in little animations here in a second. Otherwise, we're inserting somewhere else in the list. So now that previous node is actually going to evaluate to something. So now I can use it. Previous node.set next, the new node. And then the new node's next property is going to be whatever we have for the current node. This is confusing, I know. It's going to make more sense when you see it in the animation, so let's go look at that. Otherwise, if you got it and you're good with the code and you don't want to hear me drone on anymore, that's completely fine. But if you want to stick around, I'll explain more in depth. Append here has a time complexity, and its logic actually varies depending on if you have a tail pointer or not. I am down here in my implementation. I do not have a tail pointer, so mine is going to be O to the 1 time complexity, or excuse me, O to the n time complexity. Why O to the n? Because I have to traverse across the entire list. Then I just tack it on to the end. However, if you do have a tail pointer, you're going to be at O to the 1 time complexity, because all you have to do is take that tail pointer and set its next property to be the new node, and then set the new node to be the new tail. So I'm going to add a tail pointer here in a few videos, and then I'll go back and kind of refactor some of my code to take advantage of that tail pointer. But right now, I'm down here, so mine's going to be O to the n. Insert. Insert's going to be O to the n time complexity, okay? Because we have to traverse the whole list to find the index that we're trying to insert at. Our logic, we kind of already went over it. We're going to traverse the whole list, counting the indexes we're at, and keeping a pointer to the node we're currently looking at, as well as the previous node. All right, if we get to the end of the list and we haven't reached the index, that's when we raise that exception. You could return false if you want. It's up to you. It just depends how you want the behavior of your linked list to act. I'm just going to have mine raise an exception. All right, once you find which index you want to insert at. So you've traversed your list, you found the index, it does exist. That's when you need to check that previous node. If the previous node does not exist, that means you're inserting at the head. You set the new node property, new node.next to be the head, and set the head to be the new node is what that should say. So I'll fix that. This right here should say new node. So I'll fix that. All right, otherwise, if the previous node does exist, we're going to set the previous node next property to be the new node and the new node next property to be the current node. I know it's confusing, so let's actually look at it. So here's an example where I'm going to insert at the head. So remember, that's going to be the one where the previous node is going to be none. So I'm just kind of using this to say, hey, it points to none. It's nothing. I'm going to go in and I'm going to set my current node is going to be equal to the head of the list, which is going to set it to 28. I'm inserting at, let's see here, I'm inserting 93 at index 0. So I'm at index 0. Current node's already pointing at index 0. So all I have to do here is I have to take the new node and set a next property to be there. And then I set the head of the list to point to the new node. And this is what it looks like here. Okay? The head points to the new node points to the current node, the one or the head of the list as well. Okay. Now, the other example, I'm inserting somewhere else, somewhere in the middle. So this is what it looks like. I'm going to insert now 93. Now I want to insert it at index 2, so I want it to go right here in my list. Well, I'm going to iterate over my list, keeping track of what my current index is, keeping track of my previous pointer and my current pointer, and eventually, once I get to a point where I visited as many nodes as I need, right? So that current position variable is equivalent to the index you passed in, so 2. We found where we're going to insert. Well, now my previous node actually evaluates to something. It points to a node. So I'm going to take my previous node. I'm going to set its next property to be the new node I'm going to insert. And then I'm going to take the new node and set its next property to be whatever the current node is pointing at. I recommend you draw this out a couple times and try some different examples till it makes sense. Let's bring it up in Visual Go. So let's create just a random list here. And let's insert something at 2. Okay. So you're going to see here, boom. They're keeping track of their previous node. They're keeping track of, their indexes. They have a for loop that's going to iterate over how many indexes we want. They create their new node. Remember, they're calling it vertex. They're going to set the vertex dot next pointer up to this node that they found. Okay. Now they're going to set the previous node's next pointer to the vertex or the new node. And that's it. So that's how you insert. Let's watch it again. Insert. Oh, that's after the tail. Let's insert at number 1, index 1. There it is. Create the new node, set its next pointer to whatever is at index 1, set the previous node's next pointer to the new node, and we're inserted. Let's insert at the head. So that's going to be, I think that's the index right there. It's not letting me do that, 0 to 1. So basically, if we insert at the head, it's going to do this logic. Create the new node, set its next pointer to the head, set the head to be the new node. But that is all done using this logic right here. So I'll jump into my code editor. Oh, that's the append. There we go. I'll jump into my code editor here, PyCharm, and bring it up. All right, here I am in my singly linked list class all the way at the top here. So I'm going to go down to the bottom. And I've already written my tests, so I got some tests over here. I'll go ahead and comment out the insert. And we'll only deal with the append right now. So basically, I'm going to append some stuff. I'm appending 17, 23, and 100. And I'm just going to make sure that the list equals what I expect it to. So every time I insert something, it should go to the end of the list. So if I insert on an empty list right here, my list should evaluate to something with a list with one index 17. If I then append 23, well, my list should evaluate to this because I'm throwing 23 at the end. And I append 100, it should look like that with 100 at the end. I'll run my tests. We know they're going to fail, which is fine. Look, singly linked list has no attribute append. I haven't even attempted it yet, so let's go do it. Back in my singly linked list file, I'm going to define my function. Remember, the name of it is append. Takes self as a first positional parameter because it's an instance method. Takes item, the item I'm trying to add. I'm not going to do my doctoring here, but what I will do is I'll just create a new node, passing item in. Now we're going to do that thing if it's going to be at the head. So if we're inserting at the head, so if self.head is none, or basically we're inserting into an empty list, self.head is going to equal our new node, and we're going to return. That's it. That is done. So if I run this, okay, line 221 is the one that fails, and it's this assert method. 17 and 23. So basically this one passed, right? So if I comment these out, we're only testing if I can append 17 to an empty list. I can. It works out. Everything's good because it's just being set at the head. But when I uncomment these, it fails. As expected because I haven't done the rest of the logic. So let's go ahead and do the rest of the logic. Now, if we're not inserting at the head, all we have to do is keep track of our current node, and then we just have to keep iterating until the get next of whatever node we're looking at is none. Right? We know the last node in the list is going to have a next property of none, so I just keep looping until I find something where its next property is none. And in here, I just gotta put the logic to make it jump to the next node. And then finally, once I get down here, right? Once I get here, I know the current node is going to be the last node. So all I have to do is say current node dot set next and pass in my new node. Now, if I test this, all my tests pass, so we're good. If you are using a tail, you should just, be able to do something like this. Self.tail. Set next is going to equal to the new node, and then all you'd have to do is self.tail is equal to new node. That's all you'd have to do if you had a tail property, and eventually I'll have one, but right now I don't have a tail pointer, so I have to do it this way. All right, so that's the append. So let's go down here and let's look at my insert. Here's all my tests. I got a bunch of them. I'm only gonna, let's do this. Yeah, let's just uncomment them all. All right, so testing my insert. Basically, I'm gonna try to insert, right now this is an empty list, so I'm gonna try to insert an index -5 in an empty list. Right, making sure it's out of bounds, index 1 in an empty list, index 0 in an empty list. All these three should basically fail right off the bat. Other than that, I'm gonna start inserting things. I'm going to add one first because I have to create an empty list. Then I'm going to start inserting things, passing the index in, and then just making sure that the list is what I expect it to be. So those are my simple test cases. They're all going to fail right now. All right, no attribute insert. So let's create it. So we define a new function, def. It's called insert, takes self as a first positional parameter, takes item as a positional parameter, and the position or index, whatever you want to call it. It might actually make it a little bit easier to call this, index. Just because we're going to have to track three parameters, right? So we're going to have to track the current node we're at, three variables, I should say. We're going to have to track the previous node, which is going to default to none, and the current position is going to be 0. So you can call this position or index, whichever one you want. I'm going to call it index just for right now, just because I think it may be a little confusing if we have a current position variable and a position variable. All right, now what we're going to do is, as long as current node, so we're going to loop while current node evaluates to something. As long as it evaluates to something, Well, what we're going to check, the first thing we're going to check is are we at the correct position? So if current position is equal to the index the user wants to insert at, if it is, we just break. Because at that point, the current node should be pointing to the right node in the list. Otherwise, if it's not equal to the index, we got to keep track of our previous node, so we got to set that first, which is super important. Then we got to go ahead and move our current node to the right. So current node equals current node.getNext. Then we have to increment our position. Okay, so that's our while loop. If the current position is equivalent to the index or the position you're looking for, you break. Otherwise, you set your previous node to be the current node, move the current node one to the right to the next property, and increment your current position. After that, remember, we have to check if our current node is none. So this happens if the list is empty or the index is out of bounds. You asked basically to insert something which is an index that is not in our list. So for that, I'm just going to raise an index error. And we'll say an F string here, index is out of range. Otherwise, if we get down here, now we know, remember that current node, if we get here, the current node will be the node that exists at the index which we want to insert our new node at. All right, so remember what we have to do. Let's first create a new node. Then we have to check that previous node. If it's none, we're inserting at the head. So let's do that. If previous node is none, we are inserting at the head. So we're going to say new node.setNext is going to be the head. And then the head is going to be the new node. Otherwise, if the previous node is not none, that means that at some point I got down here and this line was executed, which means I'm not at basically index 0, or I'm not at the head of the list. So previous node is defined. So all we have to do, inserting somewhere else in the list. So all we have to do here is we say previous node dot set next is going to be that new node, and then new node dot set next is going to be the current node. Because remember, that current node is going to be the node that exists at the position we want to insert our node at, and that is what we're doing here. So we created a new node, we set the previous node's next property to that, we set the new node's next property to be the current node. And then when we were inserting, obviously at the beginning, we just took that new node's next property, set it to the head, and then set the head to the new node. But this is probably the one that confuses the most people. So let's go ahead and let's save this and let's test it. And all my tests ran. So I could go ahead and throw a terminal up and do all this for you, but if you have that code there, I'm sure you can play around with it in the terminal. To me, all my test cases passed, so I'm pretty confident that that's a decent solution.